Hi everyone, how are you guys? Hope everyone doing fine. In this opportunity, we will continue to exercise writing mathematical model on Google Colab and solve it using Gurobi solver. This time, we will explore a very well-known model we can call a traveling salesman problem. Traveling salesman problem search for the shortest possible route that visit a set of nodes. It can represent cities. Here we have the model. We have two parameters, we have two variables with a minimization objective function to minimize shortest distance or cost for traveling. We also have 5 constraints. In this video, we will not focus on describing how the model works, but I will focus on how to write the model on Google Colab and solve it using Gurobi solver. Without further ado, let's start this video. As usual, first we need to install Gurobi by downloading the Gurobi Pi module and import it into the Google Colab by typing pip install Gurobi Pi, and then from Gurobi Pi import. Gurobi is ready and ready to be used. Then we prepare the parameters and the data. Suppose we have 10 nodes or 10 cities, then we can write a parameters small n equal 10. The nodes needs to have distance or cost. Therefore, let's write down the coordinates of each node. So then we can calculate the distance between nodes using some formula. Let's see, we will create array node, and then we just put node, the first node as 20, and then node the next is 50. Now we will calculate the distance between nodes by having this formula. We have a parameter c represent the cost for traveling from node I to j. C will create an array c, and then for I in range n, we have a repetition for n times, and then we create the array for the first, and then another repetition. And if we have the same nodes, we will try to add another formula. So right now I create a variables which calculate the difference between distance x, okay, node j, and then distance in y-axis node I to first, second, sorry, then node j first. Okay, and then we will create a formula Cij equal math dot square root x diff and plus, by the way, this formula called Pythagoras formula. By the way, since we need to use math module, we need to import math, something like this. Okay, and then to make sure if we have the right formula, we can print it. However, we need to specify, else if we have the same, then we will specify Cij equal a big number, because our problem is minimization. so it will not get selected. Let's run print jij. Let's run it, and there we have the result. After writing the parameters and its data, we continue writing the variables. By the way, before we define variable, we create the model first by typing m equal model, let's give a name TSP, and then we write a model. Start with variable x. First we make array for variable x, and since we have two index for variable x, which is I and j, then we will use repetition 2 times for I in range n, then for j in range n, and we type x I j equal m at var. It will have binary variable, so we specify v type equal b for binary. We have another variable, which is variable u. We will write down the array first. Since variable u have one index, so we only have one looping for I in range n. So u equal I equal m at var v type, and then variable u is integer. Then we finish writing variables. We turn to objective function. We will type m set objective, and then here we have 2 sigma, right? So we need a quick sum, and then the formula is Cij multiply Xij, right? Cij multiply Xij, and then since we have 2, we have 4i in range n, and then for j in range n. Okay, since we are minimizing, so we will type m model sense equal 1 to specify if we are minimizing. Then we continue writing constraint. In the first constraint, we can see that we have here for all notation in the right part of the constraint. So we will write down repetition first for j in range n, then we type m at constraint, and then after that in the left part we have sigma, therefore we use quick sum xi comma j, right? And then we will write for I in range n, and then equal 1, xij equal 1. We have it. In the second constraint, we have similar with the first. Let's copy it. However, j, it will be changed with I, right here, the difference. And we just change I, and then we just change j. Okay. The next constraint, here we have 2 index in the left part, therefore we will need 2 repetition to specify the right part. For I in range to n, because we start from 0. Here it specified 2 because it starts from 1. Therefore, we will start from 1 to n over here, not from 2 because we start from 0. The same for j in range 1 to n. Then we type m at constraint. Okay, let's see. ui minus uj plus 1 less than n minus 1 multiply 1 minus xij. ui uj plus 1 less equal n minus 1 multiplied by 1 minus xij. Okay, the next constraint is this, right? We will split this constraint into two, since we only can have one inequality in m at constraint function. Here we have two. Yeah. For we will use for I in range 1, n, then m at constraint ui greater than equal to, and then we create another m at constraint ui stand n. Yeah, same. The last constraint specify the variable x, which is a binary variable. We don't need to write it again, since we have specified the variable x is a binary in the beginning here. Finally, we will execute the model by typing m optimize. Okay, let's run it and see how it works. Run, and we have the solution. Okay, if you want to see the result, we can always typing print m objective file, and then to see the objective function, and m runtime here to see the computational time. If you want to know the result of variable, we can always type for I in range n, and then for j in range n. We only print the variable x that is greater than 0, because that's the root point. Let's see, 9999. Okay, well, print I and j. Okay, let's see. This is the result. So it starts with 0 to 4, and then after 4, 4 to 5, 5 to 6, 6 to 7, 7 to 2, and so on and so forth. It will end up node 8. Right now, we only see the result, which is a binary, and the way we interpret this result is with connecting the result here. If you want to have the real root for the result, let's write a function. In this function, we will search for the next node after the previous node based on the binary result. Let's see, we have the function check, and then j and x. See, first we specify the result, okay, and then for I in range n, okay, if the result x j comma I. Okay, the binary result is greater than 0, and then the result is I. So we will search the next result if the binary equal to 1, and then we will return the finding. Yeah. Then we continue. Start node equal to 0. We start with 0, and then let's create another variable root equal to start node in the array. Okay, then we use the function. Let's try res equal to check start node and then x. Okay, then the root plus we will accumulate the root with this. Okay, then we will create another repetition to check each of the result. Range and -1 equal to the same. We use the function res x here. Then the result we accumulate this one. Okay, and we can see print the result. Okay, let's see if we have the result. This is the root. Okay, after we specify the binary. If you want to have more results, suppose you want to draw a map and show how the roots, we will plot this result. However, we need to another module. We call it matplotlib. So we import matplotlib. Py plot as pt. Okay. Now we try to plot the node first. Plot the x coordinate and y coordinate. And then I also will add a label showing the number of nodes. First we create a variable x customer, and then for y customer, and then for the label equal to. Then we will enumerate the root, the result, in the root. Okay. And then we accumulate this, the x customer, with the x customer plus the node coordinate. This is the node coordinate for x axis. Yeah. For the label, okay, we just use the number of nodes. Yeah. Next, we will write a syntax to plot and create the graph. Plt scatter, and this is to plot the nodes, customer, y customers, and then the color. The color is, let's say, red. Okay, and then the depth, yeah, the layer is the layer number 2. Yeah? Then we plot the root. Okay, the same x cos, the color, I will differentiate the color with a blue one. Then C border is 1. Okay, the first layer. Let's have the node is the label. Yeah, the label I will try to enumerate for e txt in enumerate label. Okay, and then plt annotate. Okay, txt x customer coordinate I plus 1 y cos minus 1, so it will not overlap with the node itself. This is the coordinate, and then PLT, then we show it. Okay, that's the code, and let's run it. Here we have the result. That's it. This is the result of traveling salesman problem. Thank you for watching this video. Hope it can help you. If you feel this video helpful, don't forget to like, make a comment, and subscribe. See you again in the next video. Goodbye.